Hello everyone, it's a great to see you all here today. We are diving into a really interesting area of AI called adversarial search. Now, you might be wondering that what's that all about? So let me break it down for you in a simple terms. Picture this, you are playing a game of chess or maybe tic-tac-toe. In this game, it's not just about you trying to win, it's also about making sure your opponent loses. You're always thinking about what they might do next and how you can counter it, right? That's exactly what we mean by adversarial search. It's all about making decisions in situations where two players are competing directly against each other. Now, what makes these kind of scenarios so unique? They fall into category called competitive multi-agent systems. That's just a fancy way of saying there are two or more players and each player's outcome depends entirely on the actions of other. It's a classic I win, you lose situation. If you make a move that gives you an advantage, your opponent will probably respond in a way that tries to take that advantage away from you. This is why we call these situations zero-sum games. In zero-sum games, any gain you make results in an equivalent loss for your opponent and vice versa. So think of it like this. There is only one pie and you have to take a bigger slice. Someone else get a smaller piece. Another interesting aspect is that the most of these games that we play known as perfect information. What does this mean? Well, it means that both players know the entire state of the game at all times. Think of a chessboard and all the pieces are right there visible to both the players. It's not like a card game where some information is hidden, like your opponent's hand. Here you can see everything they can see, and they can see everything you can see. So with all that uh, mind, the big question becomes how do we play in a that outsmart our opponent? That's where adversarial search technique come into play. Our goal is to analyze the game state and develop strategies that give us the best chance of winning while also predicting what our opponent might do counter us. One of the fundamental technique we use is the min-max algorithm. Here, the idea is we assume our opponent is going to play optimally, meaning they will try to minimize our game while we try to maximize them. We simulate various moves and counter moves, thinking several steps ahead. We look at the potential outcomes for each move and then choose that one puts that one the best possible position. But there is a challenge here. If we try to search all possible moves in a game like chess, it would take an enormous amount of time. So to make this process more efficient, we use a technique called alpha beta pruning. This technique helps us to cut away the parts of the decision tree that won't lead to useful result or overfitting of the training, allowing us to focus only on the most promising moves. It's also like trimming a tree to keep only the branches that matter. In conclusion, adversarial search is a fascinating area that brings together strategic thinking and computational methods. Whether we are figuring out the best move in the chess or making plans in real world competitive scenarios, the basic idea stays the same. Anticipate the opponent's moves and stay in one step ahead. By mastering techniques like min-max, alpha-beta pruning, and even heuristic evaluation, we can create intelligent systems that are truly capable of outsmarting the competition. Thank you everyone.